Okay, so we've got a function, I think we call this a velocity function, v of t, 1 plus t squared. So on the t interval from 1 to 2, we get this for our graph trapezoid. On the t interval from 1.4 to 1.6, we get this graph trapezoid. So, where are all my pretty colors? Got to use multiple colors for different things. Okay. Width is clearly 1. Down here, the width is 0.2. Okay. Average graph altitude is, well, between 2.96 and 3.56, the difference is 0.6. Half that difference is 0.3. So if I add 0.3 to 2.96, I get 3.26. Now you can add those numbers up and divide by 2, but it's much easier since I have a simple difference between these to do it the way I did it. You don't have to do it in your head. Although with these numbers, wouldn't hurt to try. Okay? But you'd want to check it. Okay, so the average altitude here is 3.5, and I do that by adding 2 and 5 and dividing by 2 because that's easier way in that case. Okay? And whatever's easier for you is fine. Of course, the easiest thing is punching a calculator, but if you have to punch that into a calculator, you're not thinking. Okay? You know how to do that. And if you're doing it by punching it into a calculator, you've got a bad habit. Okay? And I think there are clinics that help you deal with that habit. Well, maybe there should be. Okay. It's not that bad of a habit. But do arithmetic when you can. Okay? This is a reasonable arithmetic to do, but that one, it's unreasonable not to do it yourself. Right? It's like reaching for a calculator to add 2 and 2. Forget it. Please don't do that. Okay. Okay, so then we want to find rise, run, and slope, right? So, going to run out of colors. But the run is equal to the width. Well, the run is, of course, equal to the width of the trapezoid. And the rise is 3. Down here, the rise is 0.6, right? And then the slope is rise over run. And that's 6/7, which is about 0.86. A little less than 0.86, but pretty close. Okay, and here the slope is rise over run. 3/3.5. I just took two numbers that were closest to my feeble eyeball and did that. I'll fix that in a minute. Okay? This is 0.6 over 1 over 0.2, which is 3, right? Okay? And that slope should be 3, right? Okay? Okay, now, that's kind of boneheaded of me to choose a quadratic function, because in that case, these have to come out the same, and the other one will too. Okay? What then is the total area of the trapezoids between t equals 1 and t equals 2. So out here you got 5, over here you got 2, right? And if I break this into a whole bunch of subintervals, of course the function being quadratic has a graph that looks like this. Okay, so I'm getting a whole bunch of trapezoids. Now in the problem I say, well, we divide this into a sub 0, which is 1, and up to A100, where A100 is 2, right? And we let A1 equal, so that's 1, 1.01, 1.02, and so forth, up to 1.99 and 2. There's A0, A100, and everything in between follows this pattern. And we're asked what's the meaning of the sum of all the areas, okay? And the one thing I didn't calculate up here is area, and that's really what we're trying to get at. So let me go back and write down the area. Okay, the area of this trapezoid is the average altitude times the width, which is 3.5, right? And here the average altitude, or the area, is average altitude times width, which is 0. Well, let's do the altitude first. 3.26 times 0.2, which is going to be 0.652. Okay? Now, those are just numbers. What do they mean? Okay, well, meanings. First of all, the most primitive concept or quantities here, the basic quantities are the width and the altitudes, right? Width is your change in time, right? Okay, it's a change in time. Your time goes from 1 to 2. That's like 1 second to 2 seconds, maybe. So the width is 1 second. Here the width would be 0.2 of a second. Okay? Altitudes are what? I did specify the units. These widths are in seconds. Altitudes are, well, on a graph of V versus T, what are you measuring in this direction? T's in this direction. What's in this direction? V. And V is velocity in centimeters per second, right? Okay, so what do slopes represent? Well, what's the rise represent? Change in the value of V, which is a change in velocity, right? It's a change, it's a difference between this velocity and this velocity, right? That would be a change in velocity in centimeters per second, right? Now, of course, the run is the same as the width. So getting hard to write. Rise over run is delta V over delta T. Well, a change in one quantity divided by a change in another quantity is the average rate of change of this quantity with respect to this quantity. Okay? That's the average rate of change, which I'll abbreviate with ROC. And that's getting hard to read. Average rate of change of V with respect to T. Okay? Now, is that terminology that you saw when you were studying derivatives? So, yeah, the slope is then representing what the derivative is, because the derivative is the limiting value of the slope as the width of the trapezoid approaches zero, isn't it? Okay? So that should be a familiar interpretation to you. Now, how about the interpretation of area, because that's what we really want to talk about, so we can answer the question of what the sum of all these areas represents.